Okay, Johnny, so do you mind sharing your weight? Well, actually, how old were you when you last, like, skateboarded down the street? Okay, so you weighed 160, all right. Okay. So Johnny weighs 160, but if we're going to do a physics problem, we should probably be converting to standard metric. So there's 4.45 newtons in a pound, and how many newtons per kilogram? Because we want his mass. Yeah, 9.8, right. Gravity is our conversion factor. All right, so Johnny has a mass of 72.7 kilograms. We use 3 sig figs because he was probably accurate to the ones place, so 3 sig figs is fine. So Johnny, we're going to have you just like at a normal skateboarding speed, just coast to a stop, okay? What would you guys say the coefficient of friction would be for a typical skateboard, high or low?
90.
Yeah, I would agree, pretty small because, so let's make it 0.0 something, 0.042. Because they're wheels, so the coefficient of friction is small. Okay. What would you say, Johnny, a typical speed is on your skateboard? You're not going crazy, you're just out for like a leisurely.
Like
2 miles an hour? Okay. 2 miles per hour. Now again, we need to convert this from miles per hour to meters per second. I challenge you to do that right now. What conversion factors do you need? What do you need to know? 5 tomato feet in a mile. Yep. And there's how many feet in a meter? 3.3. Very good. Yeah. So 5 tomato feet in a mile, 3.3 meters, 3.3 feet per meter. So that'll get you to meters, and I think you should know how many seconds in an hour, right? So as you calculate, once you get this, check with your shoulder partner and let's see if you agree. All right, I'm seeing a lot of .88, or if you want to be very fussy, 8/9. Okay, so now we're in meters per second, so .88, repeating, meters per second. Johnny, we're going to have you come to a stop, okay? And first thing I'd like to know is, what is his change in momentum? Go, you've got like 10 seconds to figure that out. Okay, answer for this? This one was pretty easy, right? Negative 64.6 kilogram meters per second is the change in momentum. Why is it negative? Because he's slowing down, correct. Now, what I'd like you to solve for is the time that it takes for his momentum to change. Use the change in momentum impulse formula. Who remembers what that is? M delta V equals Ft. What's the force that slows him down? Friction. So go. So, time, Jacob, what'd you get? What's Jacob? 2.16. Yeah. 2.16 seconds to be correct. Last thing I'd like you to solve for is, and notice, by the way, the negatives do cancel when friction is the force, is how far will Johnny travel as he coasts to a stop. So he's not going very fast, it's not taking him too long. So it shouldn't be a big distance. Check with your table partners, see if you got the same thing.
Poorly drawn diagram. Someone in a car. Very large skateboard.
Okay, there's lots of ways that you could solve this. Johnny and Superior, I see you guys talking. Did you work this out? Did you agree?
Yeah.
Yes? All right, agreement is good. What'd you get? I got the same thing, 0.9596, yep. What did you use to solve for that? Average velocity, yeah, that's definitely the easiest. The average is the average between 0.88 and 0, so it's 0.88 divided by 2, or 0.44, right? So that's the average velocity, and just multiply it by the time. And I agree, you get about a little less than a meter, so 0.96-ish meters. All right, so for homework tonight, if you understood this whole problem, it's 6C number 1 and number 6. I think it's online. So do tonight's homework. Make sure you have the homework from 2 nights ago done and the homework from last night, the lab. Basically, you have just to catch up over the next few days. I promise I will do a homework